So, lately we've been reviewing what it means for a polygon to be either congruent or similar. So, can someone remind me what that means? Like, either one of them.
Both have the same meaning.
Just what is it? Yes.
Right?
What does it mean for a shape to be similar?
It means, their angles are congruent and their side lengths are proportional.
Yes. And so, when something's congruent to another shape, that means that
They're like basically the same. They have the same side lengths, same
Yes.
angles. Measures.
yes. So today we're going to take the knowledge we've learned so far and apply it to real world problems. So can you guys think of any times in your lives where you can see yourself using similar triangles to solve problems? Or just anywhere, not even to solve problems, just where can you see them?
Well, the Egyptian pyramids.
Yes,
Triangle.
you are correct.
Back to this.
Even like if you're trying to plan like a trip and you want to find like your shortest distance, you can compare one triangle to another triangle depending on like your destinations, or even like everyday things such as seeing ramps or something. So here we're going to try to apply it. This man here, Ed, he needs to figure out the height of this building, but he doesn't have anything. The only thing he has to measure are his shadows and himself. He's not allowed to touch the wall. So on your paper, I want you guys to each come up with a way that you think he could figure out the height of the wall.
It's a pretty cool looking guy. Those sneakers are fly.
You guys can work together if you need help.
This is the ratio.
I did too.
Also, each of these are
Yeah.
from the top of the building to his feet, and the top of his head to 4 feet.
So like those two are similar, that's small.
32
tiny.
and 4, and then the height and 6. So, I didn't use the hypotenuse.
Oh, okay.
I
Like that.
Yes.
And then
Is the answer?
portions?
You guys get 48. Okay.
Mhm.
Math in my head is a
And I was
little
like,
difficult.
I feel like I shouldn't have to write these like problems out, but I did.
Oh, yeah, I did too.
So do you all agree on 48? 48
Yes.
feet is the
Yeah.
answer?
Yeah.
Is there any questions in regards to how the triangles are set up in this case? Do you all understand?
Yes.
All right. So today we're going to imagine if if it wasn't a sunny day, he couldn't just use the shadows. So here, like in my classroom, I would anticipate like going outside and doing something like tall that they can't measure. But for today, our goal is going to be to measure how tall that little camera green thing, the black one right there. We're going to measure how high that is off the ground. And you are able to use the tools you have on this table, but you can't like stack the yardsticks up on top of each other. You can only use like the measurements, these tools like to measure lengths along the ground. So first I want you guys to come up with like a game plan of how you think you could use similar triangles to solve this problem and demonstrate like your model using GeoGebra before we actually use the tools to solve it. Do you guys have any questions about what we're trying
Wait,
to
so
do?
what are we finding the height from
The height from the ground, like
black
vertically down, yeah, to the
Okay.
black camera.
But we can't. Okay.
But you can't just have James stand there with his arms all messed
Because
up.
okay. All right.
You have to think of it in terms of similar triangles. Yes.
So basically, that height is like the same as idea of the height of the building. We didn't know.
Yeah, but we don't have a shadow. Cause like I think the reason you can do this with shadows like is the sun is creating
Yes.
them.
It's cloudy
so
today,
It
so we
makes it
cannot
so
use
we
makes
should
sense.
find
Similar.
so we should find like the length of like the ground floor there and measure to that wall, and then take that distance and form like a ratio between those two lengths. Maybe.
Wait, do we have to go all the way to that wall?
No.
No, but just
Okay.
hypothetically, maybe. You know what I'm saying?
Mm-hmm.
So
Some movies.
You guys have a protractor, you have rulers, a meter stick, and a mirror.
We can use mirrors for angles. I know that.
okay.
Good thinking.
Wow.
And so like this. What the heck? So these angles are the same. And these are the same.
Yeah.
It doesn't have to be set up this exact same way either. Like if you guys have
Okay.
variations of it, we're not
Well, like-
redoing this problem. We're
Yeah. So like
But we're using
our known
triangles.
quantities could be like an angle of distance
Something.
or something.
Mm-hmm.
Yeah. Well, we would know.
So like we can measure the floor.
Yes, you can measure the floor and you can use your bodies, but you can't use it to stand under there and reach up. So like if you know Tia's like 5'6" or whatever, you can use her height.
So we can find this height,
Yeah.
and we can find this height.
Mhm.
But then, how do we know how to make one that's proportional over here? That's my question.
That's the question.
Yeah, 'cause you can't know if the height's like half or whatever ratio
Yeah,
that would
because
be.
we're gonna have this.
Well, what if we? No. That won't work.
And we can find this. We just need these to be proportional.
Can we just make it proportional? Like, if like someone stands, like 4 feet away, and then like we measure like
2 feet out.
2 feet out or something, it's like 6 to 4, and so we
Mm.
does that work? Because then you can use the ratio from height to that, but I don't know if that
See,
I
works.
don't know
think
if it works.
I feel like you can't just do that,
Like, just pick a thing.
I don't think that works.
And we can't get that.
Let's think about if you have the mirror and you place it on the ground between you and the
You
camera.
can make your like.
Whoa.
Oh,
Is that what you're going for?
Yes.
Okay.
wait. So what is it?
Can you
Like you can have your person standing over here. So this is
Okay.
James clearly because it's really tall. And like he could look down and you could have your mirror right here and then like there's a certain angle that like he would see the camera and like the mirror from.
And so that's the. Wait. Wait, what?
So like, so like you could these distances would be known. So
Yeah,
like
'cause
the
we can
distance
measure
from
them.
James to the mirror and the mirror to
Yep.
this, and like there's an angle here, and like somehow that's known, I think, like or you can figure it out. And so like James would look down and he would see the mirror.
Mm-hmm.
So like
Does it change on the angle of the mirror or based on the distance between? Like, are you to figure out like
So you
where
split
he can see the
distance, what
camera?
you're saying.
Like, are you changing the angle of the mirror and like whenever he sees it, he's like, "Oh, stop at that angle," or is it like you're moving the mirror back and forth, and at some point he can?
I don't know.
Should we test it?
Yes, we can just skip. That's fine. You don't have to use GeoGebra. Let's move.
Oh, I forgot.
No, you're fine. We're gonna scoot the tables back so you guys can like use the floor.
Okay.
Just keep that there because we'll just push it back. I probably should have done before.
Oh, sorry. So this somewhere in the ground. And then like at some point you can like see the camera like right here.
Well, on this side too, or?
I-
Like
So now we just
Still
have
gonna need the
mirrors
same
here.
distance from here to the, like the split of the mirror speed.
So yeah,
the same?
we
I
need.
don't know.
Is that how it goes?
I have no idea.
Well, I think it's just like you measure from like directly here to the mirror, and like that's
one of the things.
Oh yeah, and then
one of
these
the
would
lengths,
be
and
proportional
then you
in some way.
combine it to make a bigger length.
Yeah.
Oh,
You know,
Yeah.
so like I think we have to kind of estimate like where this
I
comes
apologize.
down.
The tables are all. You can.
I mean,
We
it's
can
real
move
life.
this more.
like this.
Okay.
Is that close enough?
I'd say so.
Okay. So then it's like, oh, that didn't work.
Do you want me to?
I mean, you
put
could
my
get on
finger?
the table or move the
Am I
table.
holding my finger right?
Yeah, so we'll just guesstimate that. So that's 1, 2, 3 meters, and then we'll call it. How far should we call it? 15. So 3 meters and 15 inches. Oh, should we measure that in centimeters?
And then I'm like
And then.
a meter.
Mhm.
Alright. So,
So. Inches. And then our. But actually, we want this distance, right?
oh yeah,
Yeah.
the whole
So
thing
it'd
was
be,
like
so
my
it'd
bad.
be 2 meters and.
14
Yeah.
or 15.
So that, like that.
Yeah.
And how tall are you?
Yeah.
5'4", I think.
Okay.
That works. I think.
So we have random, what's it called? Measurements here. Okay, so.
So we should
what's
convert
me-
them all to the same thing.
Yeah, what should we convert them to?
Probably inches.
Okay. So it's like 39 and a.
So what is it, 64?
Oh, why didn't we use inches?
I because I
Isn't that
Okay.
64?
Yeah.
Yes.
Okay. And this, how much is a meter?
Wait, a meter is 3 feet, right?
3 feet in a yard.
Oh, just kidding. Yeah.
Yeah, this is a meter. Is this meter?
Maybe we should do centimeters.
Okay.
Well, it's 2.54 inches in a centimeter, right?
Yeah.
So. No,
Which one are we converting to? Are we converting to inches or meters?
That's fine.
Inches. Okay. So then 2 meters would be 200 centimeters. So that'd be x over 200.
So x equals 200 times 2.54.
Which is 234 times 2.
508 Okay.
What is the sun now?
Inches.
And then, well, I guess then 1 meter would just be 254 inches.
And then this guy would be 508 plus 14.
Which is 20, 32.
Yeah. Right?
Yeah, 532. Okay. Cool.
So now we do.
Wait, it's 22, right? 14
Oh.
plus 8.
LOL.
It's fine.
Yeah.
Yeah, it's 22.
Yeah.
Okay, so we have h over 5.2 equals 64 over 254.
Mhm.
So 64 times 522.
I feel like we should convert this to feet at the end.
I'm kind of glad we used inches and not centimeters.
Yeah.
So it's
1,300,000.
about 131.53 inches.
And then just divide that by 12.
10 feet. That makes sense.
Almost 11.
Huh.
Yeah.
How tall are you guys?
6'6".
So it makes sense.
Yeah.
It's like me and him put together.
Wow. That's cool.
I thought
Wait, you should go
It's like
measure and
blue.
see if it's actually.
Yeah,
we can try to measure it now to make sure.
See how close we are.
Yeah.
It's almost
You can just hold the thing.
Yeah, you can just hold it
hold
above
it
your
up.
head.
Yeah.
That works.
Here. I mean,
It's like almost perfect. Just
okay. So you're
like,
saying
how
Six.
tall are-
You're what, 6'6" you said?
yeah, 6'6".
So how many inches is that?
6'6".
That's 12 times
72?
and then plus
78.
78.
So 78 plus, that's about,
40.
I mean, yeah, approximately, and it's a little less than that, so that would be,
118 inches, right?
Yeah.
mm-hmm.
And then we had the extra. There were like there was.
Yeah, it wasn't all the way up
Yeah.
there.
There's, probably what, like,
9.8.
yeah, so we're right
So
there.
we're pretty-
and then
pretty
if
close.
you add on, yeah, the
Wow.
one extra bit.
That's cool.
So what kind of things do you guys think could have caused in a classroom different groups to get different answers?
Maybe my height wasn't right. Maybe
Yeah.
I lied.
Yeah,
I
and
actually
like
probably did.
where we started, like the measuring from,
Yeah,
because
could
it's
be
like,
error.
you know,
Mm-hmm.
we weren't 100% precise with that.
And like
Also,
where you saw the like where I saw the camera or the
Mhm.
thing on the mirror.
yes, because like if your head's down,
Mhm.
it's gonna be different,
Mhm.
and like if you measure from like the top of the head or to the eyes,
Yeah.
it makes like an inch, couple
Oh,
inches difference,
yeah.
which
That's
can make
true.
a difference in the end.
Mm.
So yeah, good job, guys. It's pretty cool.
Cool, cool.